Assalamu alaikum students, welcome to our online chemistry class. Hope all of you are fine by the grace of Almighty Allah. Today I am going to start a new chapter, chapter 12, the last chapter of your textbook. And today's chapter is about the chemistry in our lives and how the chemistry is connected to our daily lives will be discussed in this chapter. And in the topics given in your textbook are classified into three different categories. First of all, domestic chemistry or household chemistry, and after that, chemistry in cleanliness. The category is about the chemicals which are used for cleaning purposes, and after that, chemistry in agriculture and industries. As usual, I will request you to keep your copies and textbook with you and take the notes from the lecture, because some chemical reactions and some informations will be given in this lecture which are not available in your textbook. Whatever I write, you have to write in your copy. Okay? Then at first I will go for a very common chemicals is known to all of us is common salt or sodium chloride. Sodium chloride is our table salt. It's known as common salt or edible salt. Okay, and this sodium chloride is a ionic compound. Sodium chloride is formed by the reaction of a very reactive metal and a very reactive non-metal. Okay, it's an ionic compound. Sodium cation and chloride anion forms sodium chloride. And how? We have to know how sodium chloride is prepared. We have already know that I think the sea and ocean is the main source of sodium chloride. Okay, the sea and ocean is the main source of sodium chloride, and this salt sodium chloride is also obtained from underground deposit by mining, but in our country the water of Bay of Bengal is the main source of to collect sodium chloride. Okay, in sea water 2.5% sodium chloride is present. Okay, that's why the seawater is tasted salty. Okay, the people in the coastal area in our country around the Chittagong district at first make a square or many square or rectangular shaped dam or bed to deposit the seawater. Okay, and after that dry the seawater in the presence of sunlight, and then the raw sodium chloride is obtained and at the bottom of the salt bed, and then it is collected and with some impurities like sand and other chemical substances, and then in industry the salt is purified by different processes. The sodium chloride is purified by dissolving this impure sodium chloride in water, and after that filtering the solution and concentrating the solution by evaporation, and finally crystallizing the fine sodium chloride. But the sodium chloride which is obtained by this process is not very pure. It contains some impurities which are more soluble in water. Okay, and such as calcium chloride and magnesium chloride. Okay, magnesium chloride and calcium chloride. With sodium chloride, magnesium chloride and calcium chloride are present in this salt. And the presence of these two salts make the common salt moist under humid weather. in rainy season, you must observe that our table salt gets wet. This is because of the presence of magnesium chloride and calcium chloride salt. Sodium chloride is not hygroscopic in nature, but this magnesium chloride and calcium chloride is hygroscopic in nature. Hygroscopic means it can absorb moisture from its surroundings very strongly, very easily, and get wet. This was the whole process how we can collect and purify sodium chloride. Okay, no more chemical reactions are mentioned here in your book. And another thing we have to know, which is the importance of sodium chloride. Sodium chloride is widely used chemical. We use it in our food to not only to make the taste of our food. It is also very important electrolyte. It supplies a very important electrolyte of our blood, which is very important to keep our body active, okay, which is sodium plus. And this electrolyte we get from sodium chloride by taking sodium chloride. And another is a very important raw material for industry, sodium hydroxide. That means pure sodium hydroxide or caustic soda. Caustic soda is prepared by using the saturated solution of sodium chloride. The saturated solution of sodium chloride, which is known as brine. Saturated sodium solution of sodium chloride is known as brine. Important, very important for you. What is brine? Then you have to write the saturated solution or the the saturated solution of sodium chloride is called brine, and this brine is used to prepare another very important chemical, which is sodium hydroxide or caustic soda. And also it is used to prepare sodium carbonate and sodium bicarbonate, okay, which is known as baking soda. And in pharmaceutical industry, pharmaceuticals to prepare saline and many drugs, we use sodium chloride. Now we go for another two important chemicals, which is baking soda and baking powder. Baking soda and baking powder. The baking soda is, you already know, baking soda is sodium hydrogen carbonate or sodium bicarbonate. Okay, baking soda, which is sodium hydrogen carbonate, is also known as sodium bicarbonate. Okay, and this is the leavening agent. We know it's a rising agent and widely used in bakery. And another is baking powder. This is very popular to bake any cake, muffins or cookies, any bakery items. Okay, and now we have to know how to prepare baking soda and how to prepare baking powder. And for baking, to prepare sodium bicarbonate, we can use many different methods, but but the solve process. The solve process is its industrial process. Solve process, okay, is used in industry because this process is economically profitable. And as a raw material for this process to prepare sodium bicarbonate, we use brine, B is brine, that means unsaturated sodium chloride, and we use ammonia gas, and we use carbon dioxide gas and water. Okay, 4 raw materials are used: sodium chloride, ammonia gas, carbon dioxide gas and water. And at first, to prepare carbon dioxide gas, we take in this method calcium carbonate or limestone. At first, we have to heat the calcium carbonate, and then we get calcium oxide, carbon dioxide and these two products. Okay, calcium oxide and carbon dioxide gas. This carbon dioxide gas reacts with ammonia, carbon dioxide, ammonia and water. This is the second reaction, and then produce ammonium bicarbonate or ammonium hydrogen carbonate. All the atoms, all the reactants combine together and form ammonium bicarbonate. Then this ammonium bicarbonate reacts with saturated sodium chloride, that means brine. Ammonium bicarbonate reacts with sodium chloride, saturated sodium chloride, and produce our desired product, sodium bicarbonate, ammonium chloride salt. This sodium bicarbonate is obtained as a crystalline solid. It's a crystalline solid, and this ammonium chloride is remained in solution, and then they can easily get separated from this solution, and we get our desired product, sodium bicarbonate, which is baking soda. Okay, I hope it is clear to you. This is the solver process, industrial process to prepare sodium bicarbonate or baking soda. But still we didn't get the baking powder. Now we have to prepare baking powder. Baking powder is one of the ingredients of baking powder is sodium bicarbonate, that means baking soda, and we have to add another ingredients to it, and then we get baking powder. Okay, if we add tartaric acid, that means tartaric acid with baking soda, then we get baking powder. Then we get baking powder. That means baking powder is a mixture of sodium bicarbonate and tartaric acid, which is a dry organic acid. Dry organic acid. In your book, the molecular formula of tartaric acid is mentioned, but I also I will show you the structural formula also. Then you can easily understand the reactions. Okay, and the molecular formula of tartaric acid, it's a dry acid, C4H6 and O6. C6H6O6 is the molecular formula of tartaric acid. Now I will write the structural formula. You have to write this in your copy, okay? 4 carbon containing chain. 4 carbon containing chain, okay? And acid, this is an organic acid, that means it must have the carboxylic group, COOH group, and this is a diuric acid. Okay, tartaric acid is a diuric acid. It has 2 carboxylic group at 2 ends, and then OH and H H and OH. All the carbon fulfill the tetravalency, and this is the structure of tartaric acid. And in organic chemistry, for the functional group, this functional group, carboxylic group, and this functional group is more active than these two functional group. Student, carefully look that in this structure two different functional groups are present. Carboxylic functional group is present, and also hydroxyl group, that means alcoholic functional group, is also present. But carboxylic groups as a functional group is more reactive, more active than hydroxyl group. That's why the final product is known as acid. That's why the final product is known as acid. This is the tartaric acid, and this acid with sodium bicarbonate, this acid with sodium bicarbonate is known as baking powder. This mixture is known as baking powder, and this is also widely popular leavening agent, that means rising agent, to make any bakery items. Okay, and now we have to know how they work. Baking soda is sodium bicarbonate. Sodium bicarbonate is a base. It's alkaline and basic in nature, and so when we use baking soda in any recipe, an acidic ingredient is needed to in the recipe to react with it and produce carbon dioxide to rise the cakes or any bakery items. And if we take little excess of sodium bicarbonate and not enough acid ingredients in the recipe, then this unreacted sodium bicarbonate can make the cake soapy or bitter in taste. But in baking powder, tartaric acid baking powder contains tartaric acid, which can easily neutralize the sodium bicarbonate in it. Okay, and that's why if in any recipe there is no acidic ingredients, we can easily use baking powder to produce those carbon dioxide and to rise the dough of any baker item or cake. And the reactions will be for baking powder, this is tartaric acid, and when this dry mixture is just mixing with flour, eggs or milks, then the reaction is started up, and the reaction will be this is acid and this is the base, this is sodium bicarbonate, and when any the metallic part of this salt, sodium, replace the proton, the hydrogen ion from this acid, and the product will be, I write the molecular formula, okay, C4 hydrogen will be removed, 2 hydrogen will be removed from tartaric acid, and 2 sodium is added, and this O6. This is the sodium tartarate. This is the formula of sodium tartarate salt. Acid base reaction produce salt, sodium tartarate, and we know if in any bicarbonate or carbonate salt we add acid, then carbon dioxide gas will be released. Carbon dioxide gas released and water will be produced. Okay, and you have to balance this reaction. 2 sodium ion is needed. That's why put 2 in this formula, and 2 carbon dioxide and 2 water molecule will be produced. This carbon dioxide gas is responsible to rise the dough and make the cake fluffy and light. Okay, and this reaction, and that means baking powder is activated just mixing the all ingredients of cake, making cake. But for baking soda, for activating the baking soda, you have to apply any acidic ingredient in your recipe, or you have to heat it, then it will be activated. That's all for today. Assalamu alaikum, students.